Open up your MTT and we're going to go ahead and do a review for the quiz that's going to cover 8.1, 8.2, and 8.3. So here we're multiplying monomials, so we're going to multiply like parts. We're going to do 3 times 5 times a to the 6 times a cubed. 3 times 5 is 15. A and a, both the bases are the same, so we're going to simply add the exponents. So this is going to be a to the 9th. -2 times -5 times c to the 6 times c squared times d times d. -2 times -5 is +10. C and c, the bases are the same, so I'm going to go ahead and add the exponents. So it's going to be c to the 8. D and d, the bases are the same, so we're going to go ahead and add those exponents. So it's going to be d squared. Now we're going to find the area of this rectangle. So the area is equal to length times width. Area is equal to, my length is the longest side, so it's going to be 3x to the 4th times 2x cubed. So I'm going to have 3 times 2 times x to the 4th times x cubed. So area is going to equal 6x to the 7th. When the bases are the same, we simply add the exponents. Now we are raising a power to a power. Now I'm going to work this one the long way, and then I'm going to do the shortcut. So the long way is simply writing it 3p cubed divided by 5m squared times 3p cubed divided by 5m squared. This 2 tells me how many times I'm going to write it. Now I'm going to multiply like parts. So 3 times 3 is going to be 9, and p cubed times p cubed, the bases are the same, and so we're going to simply add them. So it's going to be p to the 6th. 5 times 5 is 25, and m times m, or m squared times m squared is going to be m to the 4th, because all we did was take the 2 exponents and add them. Now if we want to use the shortcut method, that's going to look like this. We have 3p cubed divided by 5m squared raised to the 2nd power. So what we're going to do is we're going to put in the exponents that are not showing. Now when we raise a power to a power, we multiply. So raising a power, you multiply. So we're going to multiply 2 times 1, so that's going to be 3 squared. And we're going to multiply p cubed times 2, so that's going to be p to the 6th, over, we're going to multiply 5 squared, and then we're going to multiply m to the 4th. And then all we have to do is simplify, so that's going to be 9p to the 6th over 25 m to the 4th. Notice that we get the same answer. Okay, anything that is raised to the power of 0 is 1. Alright, now this one I'm going to do both ways. We're going to do the long way and then the shortcut. So this is going to be -2m cubed n squared times -2m cubed n squared times 3m n to the 4th times 3m n to the 4th times 3m n to the 4th. Okay, so -2 times -2 is +4. M cubed times m cubed is m to the 6th. And n squared times n squared is n to the 4th. Times 3 times 3 is 9 times 3 is 27. M, and that has a 1 and a 1 and a 1, so that's going to be m cubed. And n has a 4 and a 4 and a 4, so that's going to be n to the 12th power. Now we're going to go ahead and continue multiplying like parts. So 4 times 27 is going to be 108. M to the 6 times m to the m cubed is going to be m to the 9th. And n to the 4th times n to the 12th is going to be n to the 16th. All right, let's go back, and now we want to do the shortcut method, which means we're going to raise a power to a power. So we put in our exponents that are missing, and we're going to multiply. So this is going to be negative 2 squared times m to the 6th, n to the 4th, and that's going to be times 3 cubed m to the 3rd, n to the 12th. So remember that when we're raising a power to a power, we multiply exponents. So now we're going to multiply. This is going to be 4m6 n to the 4th. This is going to be 27m cubed n to the 12th. When we multiply that, we get 108 m to the 9th n to the 16th. All right, so now we're going to need to go through and get all of our negative exponents positively happy before we can simplify. So we're going to go ahead and put in the exponents that we can't see so that we can raise the powers. So this is going to be 3 to the negative 2. This is going to be m to the positive 2. And this is going to be n to the negative 4 over, this is going to be 2 to the negative 2. This is going to be m to the negative 8. And this is going to be n to the positive 2. Now we need to get the negative exponents positively happy. So the 3 squared is going to go down to the denominator. The 2 squared is going to go up to the numerator. The m squared is going to stay in the numerator, but the m to the 8th is going to go up to the numerator. The n to the 4th is going to come down to the denominator, and the n squared is going to stay in the denominator. 2 squared is 4. M squared times m to the 8th is going to be m to the 10th. 3 squared is 9. N to the 4th times n squared is going to be n to the 6th. Now we're going to take this multiplication problem and put it into standard form and scientific notation. So we're going to do scientific notation first. So what we're going to do is group the like parts. So it's going to be 3 times 1.2 times 10 to the negative 3 times 10 to the negative 5. So we're going to multiply these together, and we're going to get 3.6 times 10. The bases are the same, so we're going to add the exponents, so that's going to be negative 8. Now 3.6 is between 1 and 999, so that number can stay the same, and the exponent's going to be negative 8. So scientific notation would be 3.6 times 10 to the negative 8. If we're going to put it into standard form, we're going to take the 3.6 and we're going to move that decimal 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. We're going to put a big decimal there and then add in the zeros, which you should be adding in adding in 7 zeros. So our answer would be decimal 1, 2, 3, 4, 5, 6, 7, and then we have 3, 6 would be our scientific. This is our scientific notation, and this is our standard. All right, we're going to do another one. We're going to group them together. 6 times 3, and this is 10 cubed times 10 squared. 6 times 3 is 18 times 10 to the 5th power. Now we have a problem because 18 is not between 1 and 999. So we're going to have to take the 18 and we're going to have to change it to scientific notation, which means right now we're going to find the large obnoxious decimal and we're going to put in a decimal with our magic pen. So it's going to be 1.8 and we have to move the decimal one place to the right. So that means it's going to be 10 to the 1st power. So now what we're going to do is we're going to take 1.8 times 10 to the 1st power, because that's what we just said equaled the 18. That's how we take 18 and write it in scientific notation. But now we need to bring down the times 10 to the 5th. Now because these bases are the same, we're going to simply add the exponents. So it's going to be 1.8 times 10 to the 6th. That's in scientific notation. If I want to put it into standard form, it's 1.8 and we're going to move it 6 places to the right. So 1, 2, 3, 4, 5. We're going to go ahead and add in our zeros and our comma. 2, 3, 4. And there it is in standard notation. Now we're going to try our division. So for dividing, the first thing that we're going to do is we're going to take 1.8 and we're going to divide it by 1.5. When we divide, we have to move our decimals. Put the decimal up there. It's going to go in 1 time, 15, 3, and it's going to go in 2 times. So this one, the larger number is on the top. So the larger number tells us where our answer goes. So it's going to be 1.2. Now, we have negative exponents. And really, before we had done the division, so let's erase this, the very first thing is to get our negative exponents positively happy. So we need to rewrite the problem, making the exponents positively happy. Then we go do our division. So our division then simplifies the number part of the equation, and that's going to be 1.2. Now I ask myself, where do I have more tens? I have them on the bottom, and how many more do I have? I have 2. Now, that would be great, except that we have to write it into scientific notation. So to write it into scientific notation, the 10 squared has to go up. So when the 10 squared goes up, the exponent becomes negative. So this would be in scientific notation. And then if I need to take it to standard form, I would go 2 places to the left and add my 0. So my answer would be 0.012 for standard notation.